Okay, our last video for today is going to deal with writing equations for inverse functions. And here's our notation. So this is what an inverse is. The f at -1, that's not an exponent. That's just a symbol, right, that we use for inverse functions. So when I want to write the inverse for this, keep in mind that we're now aware of that an inverse is swapping x and y's. That's why we get an inverse graph. So if we get an inverse graph by swapping x and y's, we're going to do the same thing with these functions. Remember, f at x is a y, so we can simply change that to this, and then then we can swap. We're going to swap the x and the y's, so we get this function. Now, the problem with keeping it like this is that no function should be in terms of x. X is an independent variable. We have to isolate for y. So we're going to do some algebra. I'm going to swap. I'm going to get rid of this 7. Right, so how do I get rid of that 7? Well, multiply both sides by 7. Right, let's times this side by 7. As a result, 7 over 7 becomes 1. Whatever I do to one side, do the other. So we get 7x equals 2y minus 5. Now isolate for 2y. Let's add 5 to each side. Okay, so let's add 5 this side. That gets rid of this. Add 5 to the other side. So we get, I'm just going to move the 2y to this side for now. 7x plus 5. And of course, the last but not least, let's divide everything by 2. Let's get 1y. Divide by 2, divide by 2, divide by 2, everything. Now, last equation becomes 7 over 2x plus 5 over 2. If you took out Desmos and you plotted this line, and you plot this line right here, believe it or not, this is a line, 2x over 7 minus 5 over 7. You have your m right here, you have your b right there. If you graph both of these equations on Desmos, you will find that they are an inverse function because they are reflected above the line y equals x. All their key points are just a reflection of that line. Let's do one that's a little more complicated right here, folks. So we're going to change f of x to y. And we're going to swap x and y. So we got x equals 1 plus y plus 2. The challenge is isolating for that y underneath the square root, but let's get rid of this 1 first. We're going to subtract 1. Subtract 1 to this side. That will get rid of this 1. Once we do this, something to one side, do it to the other. So we get x plus 1, or x minus 1 on this side. And we got the square root of y plus 2. Next task, can't subtract by 2. It's a part of this underneath the square root. That's a flaw that students are going to make. But how do I get rid of a square root? Well, if I wanted to get rid of a square root of 4, what happens if I just times it by another square root of 4? The square root's gone, because it would be equal to square root of 16, which is of course just 4. So this is getting rid of the actual radical. So we can do the same thing here. I can multiply, well, basically, I'm not going to multiply it by the square root of y plus 7. There's another way of expressing this. This is just squaring square root of 4. Square root of 4 just produces this. So if I square root this, whatever I do to one side, I got to do to the other. Square rooting that whole thing will get rid of that square root, and we will be left with y plus 2. Now, this is a FOIL situation, x minus 1 times x minus 1. So we've got to be careful that we don't fall victim to not remembering some basics that we're familiar with. So x minus 1 squared, we got to do that real quick. Let's FOIL that. I'm going to merge the o and the I, -1 and -1. And we are going to move that minus 2 over. Or actually, I'm just going to keep the y on this side. X squared minus 2x. So, of course, we got to get rid of that minus 2. And then, so 1 minus 2 becomes minus 1. And as you can see, we have this quadratic. Now, this is a root sign. Okay, so because this is an original radical, again, this could be flipped around. This could be x plus 2 plus 1. So we got a horizontal shift, vertical shift, and you only have one side of this. So because we only have one side of this, we got to be mindful that this equation right here is representing an entire parabola. But it can't, because this right here is only half a parabola sideways. So when we take the inverse of this, parts of this won't exist if I looked at it graphically, because there are certain x values in this domain that don't exist. Those same x values that don't exist here will not exist here, producing only half a parabola that we're traditionally meant to see. Okay, that's it for today, folks. I'll assign some homework on the website. Good luck.